Fire is one of the deadliest elements known to mankind. Each year, fire kills more Americans than all natural disasters combined. Fire is the third leading cause of accidental death in the home. There were 1,755,000 fires in the United States in 1998. Between 1988 and 1998, an average of 4,400 Americans lost their lives, and another 25,100 were injured annually by fire. About 2 million fires are reported each year. The Earth's atmosphere contains 20.9% oxygen, which perfectly supports combustion at any altitude, but there's a place on Earth where nothing can be ignited, within a comfortable, human, breathable atmosphere.
Hello, I'm Gary Cotliar, President of FirePass Corporation, and this is Environment of the Future. I can freely breathe in this environment, but nothing can burn here.
You can find this miracle room at the offices of FirePass Corporation in New York City. It is isolated from the outside environment with thin plastic walls and contains an atmosphere with a reduced oxygen content, which corresponds in partial pressure of oxygen to an altitude of 6,000 feet or 1,800 meters. Burning candles are extinguished immediately upon entering the fire-retarding atmosphere. Any attempt to ignite them again will fail in this atmosphere of normobaric hypoxic air produced by hypoxic generators. This highly inflammable coal igniter is brought into the room from outside. This lighter fluid is one of the most highly flammable liquids. We ignite it in the ambient air and bring it into the FirePass environment, where the flames go out immediately. A propane gas torch doesn't want to cooperate. A burning piece of wood goes out instantly. Here we try to ignite the same piece of wood in an atmosphere containing 16.7% oxygen. The Bunsen-type gas burner used in this experiment generates a pre-mixed flame different from the flame of common combustible materials and can sustain a flame until 15.8% level of oxygen. Still, it cannot be initially ignited at the oxygen level of this experiment. A candle is brought in, still burning in the ambient air inside a plastic container. But it goes out immediately upon exposure to the internal atmosphere of the hypoxic room. At 16%, we try to simulate an electrical fire. This oxygen level corresponds to an altitude of 7,200 feet or 2,200 meters, which corresponds to that of Boulder, Colorado. The wood smolders but does not ignite. Paper smolders from the high temperature but doesn't want to ignite at all. Here we can see a correlation of the height of the candle flame to the oxygen content in the atmosphere. Please pay attention to the remarkable oscillations of the flame before it goes out completely. This graph compares two oxygen-dependent systems, the flame and the human body. The Y-curve represents a decline in combustion intensity, which corresponds to the height of a stable diffusion flame, dependent on the oxygen content in an experimental environment. 100% corresponds to the maximal height of flame at an ambient atmospheric oxygen content of 20.94%. Below 18% oxygen, we see the continuing decline in height of the flame, and at 16.2%, the flame extinguishes. The Z-curve shows the dependence of oxyhemoglobin saturation from the partial pressure of inspired oxygen. As we can see, hemoglobin will be over 90% saturated, even when the oxygen content in normal baric hypoxic air is at 14%, which corresponds to an altitude of 3,300 meters. A similar drop in oxyhemoglobin can be observed during moderate exercise. What's the difference between this atmosphere and ambient air? Here we compare simplified models of three gaseous environments. An altitude air is more rarefied than ambient air. A normal baric hypoxic environment with an oxygen content of 15% is the same partial pressure of oxygen as the altitude environment at 2,700 meters, but a different barometric pressure. One can see the same amount of oxygen molecules per specific volume in both environments. However, here we can see an increased amount of N2 molecules, with a nitrogen-oxygen ratio of approximately 6:1, as opposed to 4:1 in the altitude environment. Nitrogen molecules, at common diffuse flame temperatures, do not emit back absorbed thermal radiation. Moreover, energy absorbed by nitrogen molecules is continuously removed from the active combustion zone due to the convection process. The increase of nitrogen concentration in the air is followed by a more intensive total loss of emitted thermal energy, which inhibits combustion. Is the environment safe? Absolutely. As a matter of fact, every day thousands of people around the world exercise in this remarkable atmosphere without even knowing about its fire-retarding property. At an oxygen content of 16.8%, standard matches would not ignite after the oxygen-carrying chemicals on the tip burned out. We named this level the hypoxic threshold of ignition suppression, since none of the common combustible materials ignite in this atmosphere: wood, propane gas, kerosene, or paper. This environment corresponds to an altitude of 6,000 feet or 1,800 meters and is absolutely safe for human breathing. Millions of people live at this altitude. We have determined that the hypoxic threshold of diffuse flame extinction is 16.2%, in which a majority of common combustible materials cannot burn. This can be used as a fire-preventative atmosphere in any human-occupied space, from space and aircraft to computer rooms, houses, industrial facilities, and transportation tunnels. The discovery of this phenomenon led to the invention and patenting of the FirePass systems for prevention and suppression of fires in any enclosed environment. This building has the same hypoxic environment that is maintained by the hypoxic generator at 16% of oxygen content. Nothing can burn here, and even electric wire fault and arcing in computer rooms cannot cause fire in this atmosphere. Alternately, a building equipped with the FirePass suppression system is also absolutely safe. Hypoxic agent is kept under pressure in the container on the roof. Seconds after a fire is detected, the affected floor or the whole building is flooded with the breathable, fire-extinguishing atmosphere. Most important buildings should be equipped with a dual-mode FirePass. A constant fire-retarding environment will be supported by the additional release of the hypoxic agent in case of a major terrorist attack. There will be no fire in this case, since the positive pressure inside the building will not allow the outside air in. Homeowners can sleep secure while protected by FirePass. There'll be no need to call for help. A fire on board an aircraft can be easily extinguished with the FirePass agent, providing a safe environment for passengers and crew. Airplanes of the future and space vehicles will be purged on the ground with the hypoxic atmosphere that will be maintained during the flight by onboard air regeneration systems. The same solution can be applied to submarines. Good news! There'll be no more fires in space thanks to the FirePass patented technology. Licensing is available. Military bunkers, mines, and other underground facilities can also employ FirePass solutions for their absolute fire protection. Even the explosion of a penetrating bomb would not cause any fire. Combat vehicles do not have to catch fire anymore when hit by a cumulative shell. Marine vessels can protect their cargo compartments with a constant fire-preventative atmosphere, which is safe for humans and animals. All other rooms can be protected by FirePass in suppression mode. Electric train tunnels like Eurotunnel should be protected by FirePass in prevention mode. This will exclude the possibility of a fire completely. The same solution should be applied to mountain ski trains in order to prevent the type of disaster that happened in the ski resort Kaprun in the Austrian Alps. An automobile tunnel needs ambient air for combustion engines. FirePass suppression system can provide quick extinguishing of any fire by flooding the tunnel with the breathable hypoxic agent. The problem of fire safety has been resolved. What are you waiting for? If you're serious about this, just think about this.